Okay guys, what we're going to do now is we're going to look at diagonal planes and space diagonals. Now this is useful because when we've done this, we can calculate distances diagonally across a 3D shape using Pythagoras. Now, this is where we're going to use the work that we did in the last lesson. Now, you can see here that I've put the same shape here 3 times. We're going to just work through the example on page 28, okay? But I'm going to show you how we can work with what you've just done in order to help you with this. Okay, so I've put the same shape here 3 times, and I really suggest that when you do these questions, you start by drawing this because it makes it much easier to see what you're doing. So when we have Pythagoras in 3D, so for example, we want to calculate length EC. You can see that in each of these pictures. We've been given EA, AB, and BC. What we're going to first do is we're going to draw the diagonal planes. We're going to draw those cross sections that you did in the last lesson, just to first make it clear to yourselves what you're calculating. Okay, so the thing is, as you can see here, I've drawn this, or I've pasted this 3 times, and that's because there are 3 different cross sections that we can look at that will all use EC. Okay, so I'm firstly going to draw those 3 cross sections with you. Okay, you don't need to do this yourselves normally. You don't need to do all 3. You just need to choose one that suits you. Okay, but as I said, there are 3 options, and I want to show you that so you can see that there are different ways of doing these questions. Okay, so firstly, we're going to look at the first one. This EC shape. We can make a plane, a cross section that goes from E to B. Just make that a touch longer. I'm going to use the straight lines again this time because I don't like it without them. And we can draw again the cross section from H to C. And you should be able to see then that we have a very nice 3D plane here. Okay, so we have a beautiful plane that incorporates that EC line as a diagonal. Okay, so this is our plane in this case. As I said, I really encourage you to draw this when you're doing these questions first and shade it in so you can see exactly what you're looking at. And now we just have a rectangle. So now we have a nice rectangle here that we can work with, that we can calculate EC. We're going to do the calculation shortly. But as I said, first I want to show you the 3 possibilities for what we can have. All right, next we're going to look at another option. So this time I've gone from top to bottom across the shape. What we can do now is we can instead go, I'm going to go from E to G. Let's try doing this. Okay, so we're going to go from E to G as our diagonal this time. If I make it a bit longer, maybe it lines up. That's a bit better. Okay, and then so the parallel line to that is going to be from A to C across the bottom. So we want a line from A over to C across the bottom. And if I shade this one in, you will see again that we have a really nice plane here that covers this side, the distance that we're working on, that length EC. Okay, so once we've colored this in, should have made my pen a little bit bigger, I think. Okay, so you can see that we now have yet another rectangle that uses EC. And so we could have done it this way. All right, so that's a second plane that we can use to show this surface. All right, the third option, so we have still another one. Okay, so the third option is, and you can, some of you might already be able to see what I'm going to do with this. We're going to go across the back surface of it. So we're going to go a line from E to D, okay, and another line from F to C. Okay, and if we then shade that one in, we get another really nice surface that also uses EC. So you can choose which one of these you'd like to do. With rectangles, it's usually the easiest. With other shapes, it's not always quite so easy, but it's always a good idea to sketch this first and shade it in just so that it makes it clearer for you what we're working with. So in the first example, the plane that we're using is plane sorry, we have to write them in order. EHCB. Whoops, what's just happened? It switched pages. Okay, EHCB. Okay, so that's our plane in the first one. In the second one, our plane is E, and then the next letter is G, and then C, and then A. This is also a plane that still uses EC. And then in the third option, we have gone E, F, C, D. Okay, and all of these planes has EC as a diagonal. Okay, so now we can calculate EC. All right, I'm going to use, let's use option 2, the blue one here, EGCA. Okay, so to calculate EC, okay, let's draw firstly a sketch of that shape. And I might, oh, actually, let's use EFCD because I can just do it underneath it then. Okay, so I'm going to start by just drawing a sketch of what I have. So what I have here is a rectangle, okay, and that rectangle, I'm going to label it. Okay, our label is going to be E, F, C, D. Okay, and we are trying to find EC. So we're going to try and find this lovely line from E to C. Okay, that's what we're looking for. Okay, we know we have a right angled triangle here. Now, ED. Do we know the distance from E to D? No, we don't. We don't know this distance. We're trying to find this one. So we'll call this X. And we're trying to find this one. This is also Y. Okay, EC is what we're trying to find as the ultimate answer. DC we know. DC we can see in the picture. That's 6. Okay, so you can see in this case we still don't know something. We still need to find X in order to find Y. All right, now X, we need to now draw another sketch. Okay, because ED is on a different surface. ED is on the surface EHDA. So what I'm going to do is draw that surface as well so that we can do our calculations. I'm going to do that underneath here because then we can continue on the right there. So we have turn that off. We have EHDA, and we need to find ED in order to do this. Okay? So we have to do this extra step in this case. All right, now, in this case, we know that EH is 3. Okay, EH or AD are 3. That's over here on BC, on the BC side. Okay, we also know that EA is 4. Okay, and we have a right angled triangle here, and this side here, ED, we already labeled as X. Okay, so we have a right angled triangle here that we can work with. Okay, and we're just trying to find the hypotenuse. So we can now calculate this. Now, remember our formula is a squared plus b squared is equal to c squared. In our case, A is EA, so I'm going to write it as EA squared, plus B is AD, so AD squared is equal to, and C is ED, so ED squared. Okay, now we can keep going from here. So EA is 4, so 4 squared plus AD is 3, 3 squared is equal to ED squared. Some of you might recognize this as one of the standard triangles. So 4 squared is 16, 4 times 4, plus 3 squared is 9, is equal to ED squared. Okay, so we have 25 is equal to ED squared. Now to solve this, we need to take the square root of both sides. Okay, so we're going to get ED is equal to 5. All right, so we know that ED is 5. That's our X. So back in our original picture up here, we have X. So now we can do Pythagoras over here. So again, we have a squared plus b squared is equal to c squared. Okay, now a is x, so we have x squared plus dc squared is equal to y squared. You noticed I've used different letters this time. This is just to get you used to looking at the different ways we write things. Okay, x we already calculated as 5. That was ed. So we have 5 squared plus dc is 6, so 6 squared is equal to y squared. Okay, 5 5s are 25 plus 36 is equal to y squared. 25 plus 36 is 61, so 61 is equal to y squared. And again, we now need to take the square root of both sides. So we get y is equal to the square root of 61. Now, did we want this in any particular accuracy? So yes, 1 decimal place. Okay, and 1 decimal place will give us y is approximately equal to 7.8 centimeters. Okay, so we've just calculated that. So this is how you need to do a 3D Pythagoras, okay, using your cross sections. And it's really a smart idea if you try to, as I said, firstly sketch the shape, draw in those planes and shade them. It will really make it easier for you. And then draw a sketch of the surface you are working with, just like I've done here. That allows you to then see what you are missing and what you then need to calculate extra, because you saw with this example that we had to calculate a different side before we could do the one that was missing. Okay, so that's it for that one.